Greetings, everybody, from PADT's offices in Tempe, Arizona. It's Monday, March 28th, 2022, and I want to welcome you to our podcast. My name is Eric Miller. I'm your host, and today we're going to go a little fast. I'll be honest, I'll confess, just between us. I was supposed to record this over the weekend, and we did this really fun team building thing. We went to a local kids museum, and they piled up these giant, massive piles of sand. And our team built basically a giant sand village. I guess it's a castle with a village inside. It was a lot of fun. It was a heck of a lot of fun. But being in the Arizona sun from around 8 to 2 o'clock completely wiped us out, including me. And I was dead Sunday. So I just slept. And I didn't get a chance to record this podcast. So it's a little late and it's going to be a little short. But we'll cover the main bits. So let's go ahead and get started. We'll jump right to our interview. And today we've got Aleksandr with us, who is one of PADT's electromagnetics experts. And we're going to talk about what's new in the 2022 R1 release of HFSS and Maxwell.
Welcome, everybody, to another discussion with Alex. We're going to talk about high frequency and low frequency electromagnetics in 2022 R1. So you were just telling me that you just finished giving the webinar, so this is fresh in your mind, right?
Yes, Eric, that's true. That's true.
Good. Well, welcome. I think most of our listeners know who you are, but let's go ahead and every once in a while want to take a little bit of a break to just let us know your background and what you do here at PADT.
Yes, absolutely. So, well, my name is Aleksandr, and I am application engineering lead in this case, I guess, for PADT, and mostly focusing on high frequency. My field, more SIPI, signal integrity, power integrity. But throughout the days and times, I learned that everything in high frequency is connected. So at this point, I do know a lot about everything, even low frequency at this point. Yeah, so not an expert, but I still have good knowledge enough to conversate. But my background is basically I came from EMC laboratory from Rolla, Missouri, and that's in EMC world is pretty famous lab, and so known for good minds and good research. So
great. Well, and we really appreciate it because if anybody's listened to the podcast before knows I'm not an electromagnetics person, so you helping and translate this stuff is very useful, not just for the people who are using the electromagnetic tools, but for those of us on the mechanical or fluid side who need to understand what's available and how we can use them. So I always appreciate your time on these. So we're talking about the latest release. Here we are in a new year and a new release of Ansys. So let's start with the high frequency stuff. What's your favorite thing that you think people should know about in the world of HFSS?
Right. So overall, world of HFSS, it's a really big world.
Big.
Yeah. I like this webinar which I had. It was 55 slides, and it was a short version of it. So the most exciting things is again, HFSS engineers and developers are trying to, improve the accuracy and time consumption, of course, memory consumption, everything, every time, every release, there's a lot of work done in that area. And, one way to do it is actually to optimize the measure. And so, maybe listeners remember I've been talking about mesh fusion on the previous releases and podcasts. It's still more improvements on that side, mesh fusion. Now the new technology which to be introduced is called Phi plus measure, because there used to be Phi measure and classic measure, and there's also tau measure. Now Phi plus. So now we trying to conquer the world of chips and bond wires, on a system level, that kind of stuff. So when you have a layout, right? So you have a PCB. It's a structured layered board. Now you place IC. Now you can put packages there. Now you're connecting ICs in the packages through the bond wires and lead frames and everything. So now with the Phi plus measure, you should be able to just have like I don't like call it easy button, but it kind of is. You select that, and it is trying to figure out the mesh for the whole structure. Bond wires, 3D components like ICs, packages, 2.5D structures like planar, PCB layers, everything. So, and that's technically helps to reduce the time and still bring more accurate solutions. So that's what I'm leading it with at this point.
Yeah, that's a big thing. Are they naming the meshers like viruses? Or are they using the Greek alphabet to work their way through?
It looks like it.
The Omicron mesher. Like, that doesn't make me feel good anymore. Well, that's cool, and I think it's really important. And if you really think about it, and we've dealt with this on the mechanical side, is the problem with these kind of electronics packages is you have very, very small features and relatively large features all in the same model. And so this seems to be really helping you get the right mesh in the right place.
Right, yeah. And it is mesher, but it's not just a mesher, right? Like it's a faster technology and everything. So that's why they're saying it's not really just only about meshing at this point. It's all improving the whole performance of the HFSS because it's, faster convergence. It means you have smaller final mesh, leading to the faster sweep. So everything is getting faster, more accurate, and you're basically trying to conquer the new space, right? So the complexity of the boards and structures are incredible at this point.
Yeah. And getting more complicated. It's not going the other direction.
No, yep, exactly.
Well, cool. So that's exciting, and it's going to really help users a lot, and get more accurate simulation. So what else were you excited about in that world?
Right. So once we start to, I just mentioned sweeping, right? So sweeping, it used to be just interpolating sweeps. You run different frequency points, you get results, and then you try to correlate or interpolate or something. Now there is a new kind of beta feature though still called broadband fast sweep. So what it means is basically it's taking first of all, it's more accurate as usual, takes less time, and now what's more important is that you can specify the frequency range which you will be sweeping from. So it will not just base your solution on one specific frequency point. It actually will pick some more points throughout the band, broadband. So that's it's a little bit more technical in terms of if you have special application for that. But at the same time, that's actually really good news for people who do, let's say, memory chip design, for example. Usually a lot of, you're looking through the frequency range. So you don't just trying to solve point by point anymore. You're actually trying to figure out the frequency range and see what's inside of that region. Gotcha. So that's could be another good feature to mention in this case.
That is really cool. Yeah. I'm just.
Oh, I think you're muted. It looks like.
I put my elbow on my mute button. Thinking of all the different applications that has. It's pretty impressive. So. Cool.
So, and to lead a little bit more into this, I promise I will stop talking about this exciting stuff soon. But again, mesh fusion itself is actually also leading us to the point of bringing 3 components into your project. So it has been for a while, this whole technology called 3 components. So meaning in your HFSS project, you can basically bring let's say inductors or resistors. It's a 3D structures. So you assembling it in HFSS, right? So you bring 3 components. And so previously it was designed in decrypted models were allowed in this kind of case. Now then they introduced the encrypted models.
Okay.
And now there is another level of encryption. It's called fully encrypted models. So basically you can have as much secrets putting into this 3D component as you might want or can imagine. So it's fully encrypted. So it's a little black box just with the right geometry numbers. So you can actually just place that into your board. So now how did I transition from Mesh Fusion to this is because technically that's going to be the same idea of putting the different components, assembling in HFSS. Now, specifying the priority of the mesh we want to use. So Mesh Fusion in this case will take the mesh of that 3D component, for example, and use it as a more with higher priority. And then based on that, it will adjust the mesh for the whole thing.
Gotcha.
So that's exciting part about mesh. Again, if you changing the mesh, if you improving the mesh, you're ahead of the game because it's more fast, it's more accurate, less memory being consumed. So everything, it's better and greater.
That is cool. And the point of the encryption, for those that haven't thought about it before, is that your component is being used by your customers, and you don't want to give them your secret sauce. So you want to send them an encrypted model that has the, I guess in this fully encrypted, it's got the matrix basically, but not the actual mesh visible, and they stick that into the solve, and so it's going to calculate correctly, but you can't actually see what's inside, which is pretty freaking cool.
Right. Yeah. It's true. It's literally like, usually people use the connector as the example because the connector is usually very complicated. And so like you have special companies, Molex or, Amphenol, they have special R&D groups, who are creating this whole secrets. But at the same time, they have to give it away. Like at some point when they design it and give it as the final product. So now, can you reverse engineer? Well, maybe, but it's going to be really tough. Now, when you're trying to do simulations with those components, you're killing both birds with the same stone.
Right.
So that's why encryption is perfect for that application.
Love it. Okay, well, let's move on. There's probably more for HFSS, but I want to talk about your area of expertise. Is there new stuff in power or signal integrity?
Well, yeah, there's a few things of those. The only problem with that, I guess it's not a problem. So there will be another webinar I'll be conducting. So we decided this year we're actually splitting high frequency, low frequency, and signal integrity, power integrity, splitting on 2 different webinars.
Then we'll come back and talk about that later then. I like
that. Because I know I have like not a ton more slides for that, so I don't want to take up. I understand people love to hear me talking about those things.
We'll give them a special episode on those.
Right. I'm thinking like, what, COVID is over almost, right? So like the traffic jams are back, so people are still listening in their cars.
That's right. That's right. And they won't be sad if they get stuck. I can listen to the rest of this. Yes. Well, cool. So then let's go ahead and talk a little bit about the low frequency side of things. What's new and exciting there?
Right. So low frequency, it's always a lot. It's a different application.
Right.
It's a lot of different world and lots of different improvements in that case as well. So we used to have, Ansys used to have basically a main flagship product as the Maxwell. So you hear low frequency, you hear Ansys, and then you finish the picture with the word Maxwell. It's just that. So of course there's more improvements in that area. So now there is a new feature for polyphase electrical machine ROM. So you basically trying to achieve more accurate prediction of the electrical machine design, right? So with this new feature technology, and then see how this can be integrated into the entire drive system, including power electronics and everything else. So it does help a lot to the system engineers who's trying to develop entire drive system, with power electronics, and it's all motor stuff. And now, especially when you have multiple phases, it's actually quite a bit. It's important to make sure your motor is working really well in that case. Right. Because more phases you have, more complications you're gonna get from that. So there's that new feature in Maxwell. But what more interesting to talk about, actually, Maxwell of course being improved. Maxwell of course have more enhanced algorithms and meshes and everything. But now there is a tools like a MotoCAD, which has been acquired maybe a few years ago. And let's say up to slang as well, right? So also a few years ago, and it's more already, people heard about it a lot more often. Now the thing was that Ansys is trying to bring more multi-physics approach into this whole high frequency, low frequency fields. So now MotorCAD has now, I think it's direct link with the Maxwell. So you use MotorCAD to predict the good model of the motor, and it's really intuitive, really straightforward. Even the people who don't know what motors are or how they design it, you just open the MotorCAD and go through the kind of like a wizard-based sort of page when you specify whatever you're looking for, and it gives you ideas and it gives suggestions, like, and tell you, hey, how about this kind of design? Do you like this model? And what you can do with that, you actually just bring it into Maxwell with a one click, and so that actually creates a lot more entry level interaction for the users, right? So people who, let's say, heavy users of Maxwell, they know how to design the motors, but it takes time. With MotorCAD, you can kind of design something from a template and then figure things out on the fly. Or if you are entry level, just fresh grad, and you're not really that sure about what you can do with a Maxwell, for example, well, here it is. Fire up MotorCAD, figure things out, and then bring it to the Maxwell and start looking through this. So it's a little helpful, and it's really easy to use. So that's what I like, the integration stuff. And especially, once you start, even bringing the OptiSlang into this. And OptiSlang is the optimization and the parameterization analysis tool. So then you literally can create the model from the template, then figure out what you're looking for at the end of your optimization and how many variables you want to tweak, and just let it do its thing. So, you basically come up with a standard motor, but to achieve your goals, OptiSlang will just figure things out for you and tell you, like, hey, if you change this value, if you put this many windings or something, you will end up with the goal you're trying to reach.
Gotcha.
So, yeah, life for motor designers and electrical power and electronics is a lot easier now with these tools.
Yeah, and I guess it must be being driven, I guess that's a pun, by the automotive industry, right? Electrification in the automotive industry has got to be caring a lot about optimizing these motors, where people designing a 3 horsepower motor that sat on a concrete block and turned a pump, they didn't really care too much. But they're probably more worried about reliability than they were about efficiency. And now it seems like everything's efficiency now. So that's good to see.
Right. Well, and you can think about it this way too. So the first Tesla, right? How many years it took them to do research, figure things out, get things ready, and then you would get 3 years or 4 years waiting list for your first Tesla.
Right.
So, but it has to change, because now you can see oil prices going crazy, so people will go for electrical really soon.
Right.
And now all the cars, Rivian, our customer, right? So Teslas and everybody will have to be a lot faster, because otherwise it's not gonna work out.
Yeah. Somebody else is gonna get there before you if you don't. Yeah.
Exactly. Yeah. And now actually, I little story from me. So I went to the Harley dealership because I was looking for nice bike, and I got one.
Congrats.
Thanks. But I didn't know that they actually have really nice e-bikes nowadays.
Oh, I didn't know that.
Yeah, and even Harley. And I was like, well, how do you feel about Harley being e-bike? That's a little bit contradictory, because and I was like, oh guys, come on, let's not pay attention. And then I was waiting, and I was like, okay, fine, I'll click the button. I look around, and I was like, it performs well, great power, great motors, great batteries, everything is amazing. I was like, oh my god. So Now it's a different game now. I mean, it's
That's a good point, and I know there are Ansys users at Harley Davidson, so that's good to know that they're
well, good. I'm
doing
supporting them.
Yes. So you're helping pay for their licenses, yes.
Yes.
Good. Well, that's exciting, and yeah. So what else in the anything else in the low frequency world, or is it just mostly around motor stuff these days?
Yeah, motors. There's toolkits, the motor toolkit as well for machinery. A lot of good stuff for that. We're also trying to now bring more HPC powers for the motors as well. It takes a while to solve really complicated models, especially if you're trying to do some system level. So that's why HPC is being heavily pushed. In this case, MPI starts supporting different features and stuff. SKU models, for example, or anything like that.
Cool.
What's more interesting, actually, one more thing about this is that we also started bringing more concept of the noise, vibration, and harshness analysis into
very
it.
Important. Yeah.
Right. It is very kind of fun area, which if you don't discover, you could be in a muddy waters once you design something. And it kind of goes along with the temperature analysis being introduced, like in Elite's wire loss prediction. So, and it's actually very similar to what high frequency has right now. It's the two-way thermocoupling. So, which means you predict the EM losses, you give that data to the temperature analysis, probably iSpec tool in this case. You give them to develop the temperature maps. Then you give those temperature maps back into the Maxwell to redefine or adjust EM losses, and you can back and forth until you're satisfied with the accuracy level. And so again, low frequency goes with the temperature, hand to hand. So that's why it's kind of important to have really good feedback temperature in EM losses. So, and that's a feature now. So it's definitely users can have fun with that too.
Good. Yeah, it is. It's good stuff. And the multiphysics, of course, is important. And, early, the guys getting close on over 15 years ago, PADT did some motor design that didn't have the calculation of the vibration and noise. And it turns out it was a really loud motor.
Yeah, you don't want that.
Yeah, and we didn't find out until we built it, right? So this is a classic example of simulation being so important. If we had the tools today that we had then, we could have run it very quickly and gone, oh, this thing's gonna. It had to actually had a resonance that was right at one of the key diameters, and so basically the back of it was a sealed motor because it worked in a hydrogen environment, and the whole back face of the enclosure was at the operating speed resonance, or not exactly, but it was a 5x or 6x or something like that. So it was really annoying. We changed that. We changed that frequency. But we would have known before we built it with this. So that's good to know those tools are there.
Yep, that's true. That's true.
Yeah. Anything else you want to share before we wrap it up?
Well, out of all the good features, there's lots of features actually. Yeah. And honestly, anyone who wants to have a little deeper dive into this, please listen to what I talked about this morning on the webinar. I don't know, we will have recordings of this. I'm pretty sure it's in the Bright Talk somewhere.
Yes, it'll be in Bright Talk. Yep.
Yeah, so it's good. The only one thing I would probably just want to mention is it's the HFSS SBR Plus. Okay. Kind of shifting gear back into the high frequency, but this is something which is interesting because it's not a traditional application; it's a little different style of application. So SBR Plus, shooting box array, right? So what it does is basically you have the bunch of different antennas, transmitters, receivers, and the idea to use SBR Plus technology is to try to predict how the ray is gonna basically go and interact with between transceivers and receivers. So the thing with SBR Plus, it's usually trying to, let's say, lighter systems, right? So that's the idea, because it's a little different example, but still different idea. You're trying to see where's the light and how the ray is gonna look at everything. Now, with SBR Plus, new improvements, I guess we should call it improvements and enhancements. So it got a lot faster.
Okay.
It got super much faster. So the example which I was introducing in the webinar, I mean, I was not part of this, but I got slides from the Ansys, and I actually think I saw that paper during one of the summits actually. So the case which they're describing, it has 8 transmitters and 16 receivers. So think about like 8 objects basically, and 8 of them are transceiving. So now 8 of them are receiving, and maybe someone else is also receiving. So so the thing is, it's basically 128 channels total, right? Okay. So you multiply that because everything is interacting to each other, all the different receivers, and it's real high frequency. It's 77 gigahertz. So we're pushing 5G technology and 6G now. So, and that's a complicated case when you have that many channels. You're trying to understand how they're going to work and, understand the angles and versus range. It's, special definitions, kind of like how, let's say, a car can see the different cars on the road, autonomous vehicles in this situation, right? So now the thing is, with that example, with 128 channels at a 77 gigahertz, so we used to be able to use SBR Plus, which is not really memory consumer, like not the biggest memory consumer because it's using the shooting rays.
Ray tracing, yeah.
So, but still, it was not taking too much memory, but it takes a lot of time to calculate, go from one to another kind of, channel analysis. So now it used to do this one problem for 1 hour and 43 minutes. Now on the same exact system, same example, but now with this new feature called fast let me double check. I don't want to throw some names.
Get the wrong, yeah.
Right. So fast frequency loop, right?
Okay.
So fast frequency loop. So with that feature being on, and that's why this whole thing is very exciting. From 1 hour 43 minutes, we going down to guess what range of time? It's a 17 times acceleration, so it's only 6 minutes.
Wow.
6 minutes.
That's a game changer. That's a game changer. Yeah.
It's kind of crazy. Yeah. So that's why, I'm thinking now that will allow people to do a lot more complicated scenarios. 128 channels for 6 minutes, easy. And the system was not too crazy as well. It's only 6 cores and 64 gigs. Okay. So, I'm thinking if any of our customers have a crazy scenario when you have, let's say, autonomous vehicle in New York, when you have another 100 of other autonomous vehicles driving around, people around in the Times Square, you have all the different devices around, everything. So it should be able to simulate everything like that. Yeah,
big
it should
stuff. Wow, that's a game changer. Yeah. So instead of a tightly controlled situation, you can get into real world situations now with that kind of.
Yeah, exactly.
Yeah. Wow, that's impressive.
So that's why I wanted to keep this little feature for the end of this.
For the end, that's cool. That is really cool, and we're going to see more and more of that, right? I mean, that kind of simulation just going to have to become more and more common. Yeah. Well, cool. Wow, that's a lot of good stuff, and that's just scratching the surface. That's just the top.
Oh, for sure.
So we'll definitely provide information on how to get to Bright Talk to hear the rest of it, and we'll look forward to learning about the power and signal integrity stuff when we get to that as well. So
yeah, I think it's scheduled for May. So if anyone wants to put things on the calendar, I mean, I have no idea how May looks like. I mean, in this kind of world, it's a little crazy, but
yeah, who knows? May's a long way away.
So yeah, but it should be in May somewhere.
Okay. Well, great. Well, always appreciate your time and educating me and our listeners and letting people get excited about the world of electromagnetics. And like I said, we'll look forward to talking about the next bit. And other than that, enjoy the rest of your week.
Absolutely. Well, thanks, Eric. And then I hope that was informative. And
it was. Yes.
If anyone who wants to have more discussions, let me know. I will be happy to help.
Yeah, please do reach out. And we obviously like talking about this stuff. So good. All right. Well, take care and we'll talk soon.
All right. Take care, Eric.
Bye.
Thanks, everyone. Bye.
And as always, we want to thank our wonderful tech support engineers for joining us and taking the time to explain things to me and our listeners. And the webinar that he spoke about is available on brighttalk.com. And as always, with all of our webinars, if you go to brighttalk.com and go ahead and just search for PADT or even Ansys generally, you will find our webinars, including this one. So please do take advantage of that. And we look forward to learning more about some of the other electromagnetic products through the next couple months here. Next thing I want to do is take a look at the news very quickly. So stock-wise, the ANSS stock, as of Monday morning, right now, it's 8 o'clock Phoenix time, so the market's been open for a little bit. It's down 21.6% year to date, so for the quarter, basically. As a reference, the S&P 500 is down 4.7%. So underperforming the benchmark there. But so are all the other stocks that are kind of in our industry of simulation kind of stuff. And I'll cover those at the end of the next month when the quarter's over, and we'll compare them. But yeah, it seems like this industry is taking a little bit of a beating right now. So we'll just ride it out. In news, there's two important stories that I thought would be worth mentioning. One is really important. Ansys announced that they're making a financial contribution to support Ukrainian refugees. As I mentioned earlier in the podcast, a couple episodes ago, they suspended business operations in Russia and Belarus in order to support the Ukrainians and the effort there. So Ansys is no longer doing business right now in those two countries, including the channel partners. And just now, a couple days ago, they went ahead and made an additional donation to Doctors Without Borders to help refugees, Ukrainian refugees. So Ansys is doing their part in the conflict in Europe, and then which is great, and we're great to see them. And it shows what a good company they are in a lot of different ways. Also, two press releases that you should be aware of. They're both about how Ansys collaborated with customers to come up with better products for the customer. The first one is with Microsoft on chips, and they did a great job of helping Microsoft really streamline their process so they can design their own chips. As you know, the pendulum is swinging back to where companies are designing their own chips instead of using other people's chips, and that's why we're seeing the growth of foundries as well, so people can make those chips without having their own manufacturing facility. And then also the other one is how they worked with Vestas, which is the wind turbine company, on their controllers. So if you've been following Ansys digital twins and some of the other stuff, wind turbines have been a great application for that. And this goes more into how that control software and the controllers themselves are simulated using Ansys products. So that's good. PADT-wise, we don't have any news worth sharing. Nothing exciting going on here. We're just working our way through the end of the quarter here. In our blog, or actually, let me talk about the Ansys blog first. So one thing that I would really like to point out that kind of really got me excited was an article called Ansys Forming Provides a One-Stop Shop for Metal Stamping. So if you remember, Ansys acquired LS Dyna a few years ago now, and they've been working really hard on a product called Ansys Forming. And this is a tool that allows you to set up and run LS Dyna, not getting down into the weeds, but from a sheet metal forming perspective, metal stamping perspective. So do take a look at that. Even if you don't do a lot of that, you may make products that have sheet metal. It's a pretty cool tool. We've been using LS Dyna here at PADT for 20 years to do metal forming, and we're really excited about this new tool. It's going to make our life a lot easier. So we'll try and get somebody on to talk about that in the near future. Another one that's near and dear to our heart here at PADT is an update on best practices for gas turbine combustor meshing. It's called 5 Best Practices for Gas Turbine Combustor Meshing. If you don't know gas turbines and their combustors, they're probably the most difficult, if not one of the most difficult things to mesh for fluids dynamics, because they've got tiny little features and really big features, and because you're doing combustion and very complicated turbulent flow, the mesh is really sensitive. and it can be quite large as well. So you want to be able to get an efficient mesh in there, so you don't have to have too many elements. And so it's just hard. And Ansys has made significant strides in making it easier and easier. And one of the things they've done besides making the code better is they've been sharing best practices. So even if you don't do gas turbine combustor meshing, I recommend if you do CFD meshing of any kind, you take a look at 5 best practices for gas turbine combustor meshing. Some good advice in there. And then the last, I read it because I liked the title, but it actually turned out to also be really useful and made me think about some products that we've been working on here at PADT. It's called Replacing Bolts and Screws with Magnets. Wait, what? So there, in fact, we have a customer that makes magnetic switches that can replace bolts and screws and bolts. And there's other applications for it as well. So you can fasten things with these really, really strong magnets. And the article goes into some really good detail about how you can use Ansys Maxwell to see if it's going to work. Will it have enough force to hold things together over time? So take a look at that, really useful. On the PADT blog, as I've mentioned in previous podcasts recently, we've launched our new website. I hope you all have been enjoying it and checking it out. Some of the really old blog posts got kind of munged, and they were pointing to PDFs that weren't there anymore, or they were pointing to images that weren't there anymore. We fixed, I think all the PDFs have been fixed. So if you go there and people are still getting useful information out of 10, 15-year-old articles or 5-year-old articles for that matter. And so all those PDFs, we went and made sure all the PDFs were connected. But some images may not be. We'll work on that over the next couple of weeks. We've moved the blog like 4 times, and every time it gets a little freaky. So we're going to go ahead, since this is a permanent home for a long time, and make it stick this time. So do let us know if you find something that's not working on the blog. Just shoot an email to info@padtinc.com. And also, the last article we had was on our Pi Day. So if you haven't read that, do take a look. This year we had our math competition, and we also gave away some free Pi-related swag. So it was kind of fun. It's always one of our favorite events here at PADT. And do check it out, especially if you want to do your own Pi Day at your own company. I've got the quiz that we used. You can reuse it. Feel free to do that. And I've also got some suggestions on some other things you can do for Pi Day, as well as some resources and links to go to. So check that out. And upcoming events, we've got a webinar on Wednesday here at PADT. And it's actually one of these ones where we talk a little bit about how to use Ansys in a specific industry. And I'm actually going to our website, our new website, and the events page to make sure I get it right, the date and time. It's called Simulation Best Practices for Vehicle Engineering. So it's really for people in the vehicle space. We don't call it automotive anymore because it's expanded into a lot of other areas. And that's going to be on the 30th at 11 o'clock Phoenix time. Also want to let everybody know that we're going to be at the 37th Space Symposium. We're going to be in the Arizona Space Industry booth, and that's from the 4th through the 6th at the Broadmoor there in Colorado Springs, Colorado. So if you are going to be at the Space Symposium, please do stop by. Please do check out the Ansys/AGI booth as well. Some really cool stuff about the integration between, which we talked about in a very recent podcast, the integration between AGI and Ansys. The next webinar for Ansys users is going to be on April 6th, and it's called Transforming Digital Engineering with Ansys Discovery 2022 R1. So we're going to talk about all the cool things you can do with Discovery. And that'll be while we're in Colorado Springs. And then another shout out for another conference to please stop by and say hi. We're going to be at what is now called IME West. It's Design and Manufacturing West and MD&M West and about 4 other conferences all thrown into one. That's at the Anaheim Convention Center from the 12th through the 14th. PADT has a booth to highlight our simulation, both Ansys and our consulting services. And I'm going to be hosting the Wednesday, one of the panels not a panel, but the whole session in the conference on Wednesday. We're going to cover a lot of different topics, including a panel that I am hosting as well on doing production with additive manufacturing. So if you're going to be at Anaheim, please stop by and say hi, either in my room or when we're in the booth, and we'll have different people in the booth while we're there. And then another a webinar to be aware of is Optimizing Engineering Workflow Propulsion Systems Design, and that's going to be on April 12th. And if you're interested in 3D printing and you're in Texas, the Stratasys bus, we call it that, it's actually a truck, is making its tour, showing off new machines. So instead of you coming to the 3D printers, we bring the 3D printers to you. It's going to be in Austin on the 7th, and then it's going to be, waiting for the page to update, moving over to Los Alamos on the 12th, Albuquerque on the 13th, this is all April, Flagstaff, Arizona on the 18th, and here in Tempe at our headquarters on the 20th. So feel free to stop by and see that. You just go to our website, our events page. You'll see it and be able to make a reservation to come and see all the cool new equipment that Stratasys makes. They used to only make fused deposition modeling and then PolyJet, but now they have SLA, stereolithography, and the new SAF technology, which is kind of like a fusing technology, a powder fusing technology. So you should check all those things out. If you're interested in additive manufacturing, as that truck makes its way around the country. And that, I think, is pretty much it. Covered all the topics. Oh, one last thing. Ansys has Simulation World coming up on May 18th. I mentioned it in the last podcast. Just go to simulationworld.com and you'll find it. Register. It's virtual again, and lots of good discussions on how to use Ansys from less of a technical, what buttons to push, and more of a process and getting the most from your investment standpoint. Are you using the right Ansys tools? Are you using them in the right applications? And how do you set processes and tools in place to get the most out of your Ansys investment? So do check that out. And as always, I want to thank you for listening. Please do spread the word and let others know about the podcast. And if you can, subscribe to whatever podcast tool it is you use to download the podcast. And don't forget to subscribe to www.padtinc.com/opt-in. And that is for our newsletter, which you'll get once a month, which gives highlights of everything going on here at PADT. And as always, don't hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 108. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.